We are going to look at one cycle of a sine and cosine graph so that we can see the effect of phase shift. So here we have an equation, a trig equation, and we're going to see what the graph is going to look like. This is going to look very similar to transformations that we've done on quadratics, where the coefficient in front is the vertical stretch and the number inside the parentheses is the horizontal movement, and the number at the end is the vertical movement. So this graph has a phase shift. It has x minus 30, which creates a phase shift or a horizontal movement of 30 degrees in the opposite direction, so in the positive direction. So we know that the beginning of the one cycle that we're going to graph is going to be at positive 30. These graphs that we're going to do have a period of 360 degrees. Sometimes that period is different, but the ones we do are going to be 360. So since the beginning is 30 degrees and the period is 360, we know that the end of our one cycle is going to be at 390. So since the whole period is 360, to find the middle of the graph, we're going to take 30 plus 180, and that's going to give us a 210. So now we're going to look at our table. To graph a regular trig function that has not been shifted, we typically use 0, 90, 180, 270, and 360 degrees. But since this one has a phase shift, we are actually going to add 30 to all of those key points. So now, instead of plugging in 0, we're going to plug in 30 into our equation and see what that does. So if you plug 30 into the equation, you get a y value of 1. So we're going to plug all the rest of the values into the equation, and we get 4, 1, negative 2, and 1. Notice we're plugging the shifted values in, not our starting values. So now we're going to graph the points, and there's our sine curve. So we see that this sine curve has been shifted 30 degrees in the positive direction, and it looks like it's been lifted up 1. Let's look at the amplitude and the midline. We can see that the amplitude is 3. Our wave goes up 3 and then down 3. We've only graphed one cycle, but it would continue in this manner, up 3, down 3. The midline is the equation y equals 1. Okay, let's look at a cosine curve. This one also has a period of 360. I haven't changed that. And the beginning is a positive 60 degrees. So this one is going to have a phase shift of 60. Since it has a beginning of 60, to get the middle of the graph, we're going to add 180. And to get the end of the graph, we're going to add 420. Now, since it's going to go all the way to 420, I'm going to use a graph that goes a little further. So now I'm going to add 60 degrees to all of my starting angles, and that gives me my shifted points that I'm going to plug into the equation. So I'm done with the starting angles. So next, use your calculator, just a regular scientific calculator, and plug those values in to get the y values. Next, you're just going to graph those points. Okay, we see that a cosine graph starts high and ends high. So there's our cosine graph. To look at the amplitude and the midline, for this one, let's look at the midline first. So the midline is the equation y equals negative 1. We can see that that is the average of our high point and our low point, or it goes right down the middle. And we can see that our amplitude is 2. The wave is going up 2 and down 2 and would continue in this manner. So hopefully that gives us a better understanding of phase shift, amplitude, and midline.